Hello, everyone. Welcome back. Today, I'm going to be talking about measures of spread with regard to standard deviation and variance. Last time we talked about ones with like the median and the quartiles, that sort of thing of where's the first 25%, the next 25%, the next 25%, and then the last 25% of the data. Today, we're going to be talking about deviations, which have to do with how far from the mean is the rest of the data, basically. So, a deviation is the difference between an individual value of the data set and the mean of the data set. So, how far from that mean is it, right? The standard deviation is a specific deviation that's calculated to indicate the extent of deviation for a group as a whole. So, how can we calculate the standard deviation? So basically, to do that, what we need to do is we need to add up, find the summation of x minus the mean. So x just represents one of the data points, and then this mu sign, this represents the mean, and then squared. So basically, it's saying take every data point, subtract the mean off of it, and then square that value, and then add up all those values. So that's pretty tedious work if we think about it, right? That's going to take us a long time, right? Is to do all of that, right? And then after that's all done, after we've completed all that and found that number, divide it by n, which is the number of people in that population, and then take the square root. If we don't take the square root, then what we have is called the variance, not the standard deviation. So variance and standard deviation are related because the variance is just the standard deviation squared, or alternately, the standard deviation is just the square root of the variance, right? So in terms of these two here, they're almost the same thing. The only difference, other than the n minus 1 here, which we'll talk about in a bit, the only difference is that this is the population, the overall standard deviation. So let's see, overall standard deviation. And then the other one here, this is the sample. The sample. Standard deviation, right? So let's say we're taking the standard deviation of an entire population, then we are going to use this one here. And then over here, we're going to do the sample standard deviation. So this symbol here is going to tell us the overall standard deviation. This S indicates a sample standard deviation. Okay, in terms of the formulas, they're very similar. The only difference is that here we're going to be doing n minus 1. We're dividing by n minus 1 rather than n. And then in terms of this symbol, they changed mu to x bar because mu, this represents the overall mean, whereas x with the bar on top of it just represents the mean of a specific sample, okay? So in terms of what you do to find standard deviation, whether it's population or not, is pretty much the same thing, but there is just that one little slight difference there. In terms of other differences you see in the equations, that's really just a difference in notation, not a difference in actually how we'll calculate it. So yeah, so that's basically it. So I want to reiterate one more time, how do we actually find a standard deviation? What we do is we take each data point, we subtract the mean off of it, then we square it, and then we add up all of those values that we've done that to. Then we divide by n, the number of overall values, or n minus 1 in the case that it's a sample. And then we take the square root of that, and then we found it. So in terms of calculating it by hand, unfortunately, it takes quite a while. It's not a very nice process, unfortunately, but that's how we do it. Okay, so the variance is equal to the square of the standard deviation, so that's pretty straightforward. If we want to find the variance, we just don't take the square root at the end, or if we have the standard deviation already and want to find the variance, we just square it, and then bam, we're done, which is good. And then let's talk about a little bit about this more. It says the closer that the standard deviation is to zero, the less variation there is in the data as a whole, which means most of the data are clustered around the mean. So if our standard deviation is close to zero, it means more of our data points are really, really close to the mean. They're all kind of shoved in there. Whereas if we have a large standard deviation, then that means that the data points, they branch out quite a bit from the mean. Okay, and so that's a long story short kind of way of describing why do we want to find the standard deviation and why is it useful, right? Now let's talk about, well, how do outliers impact this, right? How would having an outlier change the standard deviation or the variance? Well, the thing is that outliers matter greatly in terms of the standard deviation, right? They would raise the standard deviation or variance, regardless of whether it's a small outlier or a large outlier. Because remember that whether we have a really, really small number or a really, really large number in comparison to the data set, we're not measuring the values in the standard deviation. What we're measuring is how far apart from the mean are these values. So whether we have an outlier that's really, really small or an outlier that's really, really big, or both of those make the standard deviation overall raise, right? Because standard deviation is measuring how far apart are the data points essentially. So outliers make it go up. So to answer that question concisely, outliers result in a higher variance and standard deviation. Good. All right. The number of wins during the last 13 seasons by Buffalo Bills are these values. Calculate the standard deviation and variance of the data set. Okay, so to do that, where there's multiple steps here. First, we need to find the mean. Now, my first question is, would this be a sample mean or a population mean? Well, let's think about that. The number of wins during the last 13 seasons. Well, this is all of them. This isn't just a subset of them. It didn't say, well, 5 of the last 13 seasons wins are displayed by here. No, it's saying that this is all of them. This is the full set. And so therefore, we can conclude that this is going to be the population mean. Okay? So what we'd like to do here is we're going to calculate for mu by adding up all of these numbers, 6 plus 4 plus 6 plus 6 plus 6, etc., all the way till we get plus 13 plus 11, and then we're going to divide it by 13. So if we do that, we're going to get, let's see, I'm going to grab out a calculator and let's punch all those numbers in. Let's see, 4 plus 6 plus 6 plus 6 plus 6 plus 9 plus 8 plus 7 plus 9 plus 6 plus 10 plus 13 plus 11. Then press your equal sign. Then divide by 13, and we end up with 8.23 approximately. So that's our mean, okay, 8.23. Now we want to figure out the standard deviation. Okay, so how do we find out the standard deviation? Well, again, the standard deviation is equal to the square root of the summation of the x minus mu values squared over n, right, over the total population, which is equal to what? Well, this is equal to the square root of something over 13. We first have to find this missing category. So let's try and find this missing category. So what must we do? We must take each value, subtract the mean, and then square. Okay, so for the first value, we must do, let's actually write down the wins and do kind of a little table here to make this easier on ourselves. Because let's be honest, standard deviation is not the most fun thing to calculate. It takes a lot of time, certainly a lot more time than some of the other methods. But that said, it's also important, so we will do it even though it takes more time. And then here in this column, I'm going to put my x minus mu values, and then in this column, I'll put my x minus mu squared values. So we'll kind of do it in progressions there. And then we'll add up all these numbers and find the total. for all is blank. The big $1 million question is, what is our total? Good. So let's write down our wins. We have 6, 4, 6, 6, 6, 9, 8, 7, 9, 6, 10, 13, 11, right? Those are our numbers of wins. I'm actually going to draw kind of lines here. We have some repeats, so that will make it slightly easier on ourselves than if we didn't have any repeats. Okay, so what is x minus mu? Well, the x value is 6 in this first case, and mu we said was what? Mu is 8.23, so this is going to be negative 2.23. And actually, I'm going to fill that in for all the 6's because all the 6's are going to be the same, right? Good. Oh, and there's another 6 here. Awesome, already filled a bunch in. What about 4 minus mu? Well, 4 minus mu is going to be negative 4.23, so that's there. What about 9? That's going to be 9 minus 8.23, which is 0.77. What about 8 minus 8.23? Well, that's going to be negative 0.23. Awesome. And then we have, let's see, 7 again. Well, I think we did that one. Oh, no, we didn't do that one. That one's negative 1.23. We have 9 again, which is 0.77, just like before. Then we have 10 minus our mean, which is 1.77. Then we have here 4.77, then 2.77. Awesome. So now what we've done is we've taken each of these values in our original data set and we have subtracted mu from them. We have subtracted mu from each and every one. Now we need to square all these values. And keep in mind, when we square something, it's going to make it positive. And so when we have outliers, whether they're, making the x minus mu value really, really small, right? Like really far into the negatives, or really, really large, when we square, it's just going to make a larger number overall. So that's what we meant earlier when we said that having outliers, things that are further from the mean, is going to result in a larger overall variance or standard deviation, because we're about to take all these numbers and square them. And so all that's going to matter is how far away they are from the mean. What is not going to matter is whether they're positive or negative, because the square makes all numbers positive. Well, all of these positive or zero, right? Never negative. Good. So now what we have to do is square these numbers. So we'll get 4.97 here, 4.97, 4.97, 4.97, and we have one more, 4.97. Okay. What about this one? Negative 4.23 squared is 17.89. Here we have 0.59. Negative 0.23 squared is about 0.05. 1.23 squared is 1.51. 0.77 is 0.59. We square that. 1.77 is, I think, 3.13. 4.77, let's see, 22.75. And then 2.77 is 7.67. Awesome. So now we've done all that. So now what we need to do is we need to add up all of those numbers. So let's grab our calculator out and let's add up all of those numbers. Okay. So 4.97 plus 17.89 plus 4.97 plus 4.97 again plus 4.97 again a third time, plus 0.59 plus 0.05 plus 1.51 plus 0.59 plus 4.97 plus 3.13 plus 22.75 plus 7.67. So finally, at long last, we find out that the answer is 79.03. So 79.03 is our answer here. 79.03. Okay, so now we've got to divide that by 13 and take the square root, which, that seems relatively easy compared to everything else we had to do today. So if we do that, we end up with 2.47 approximately, like that. Alrighty, and then so that's going to be our standard deviation. Is that what the question wanted? Oh, they wanted standard deviation and variance. Okay. Well, variance, luckily for us, variance is, this symbol here, and that's just going to be this squared. So that's going to be 6.07. And I'm going to write a quick conclusion here, just to conclude. Standard deviation would be 2.47, and that variance is 6.07, like that. Good. All done. All done for this one. Okay, so there's the first example, and I standard deviation and variance. It's not that they're hard; it's that they're tedious and they take a while, right? I mean, how long did it take us to answer one question? A long time, because there was a lot of subtracting, a lot of taking the square. Then we had to add up all the numbers. Then we had to do more stuff. So it's not that it's hard. It's just that it's tedious. And if you make a small error somewhere, it can completely mess this up. And that's why in practice, like on a test, you'll have to do this by hand. But in practice, professionals do not do this by hand. Okay, especially when they have a big data set that has hundreds of data points. They don't do this by hand. They would never be done, probably, at least not for a few days. And so what they do is they put this into computers. So you can make a computer program like an Excel spreadsheet or something even to calculate this for you. And, or some sort of programming software will often do it with math tools, or, using R, if anyone's ever used R before, that sort of thing. Um, that's what professionals are going to do. They would not actually do this by hand. I do think it's important to do a few of these by hand, like in this class or in the near future, just so that you're aware of how it works. Like, how does the computer calculate it? What is it exactly doing? However, whenever you have a huge data set of hundreds of points, it doesn't make sense to waste your time doing it by hand. It makes a lot more sense to just use a computer program to do it for you. A computer can do this a lot faster than a human can. Good. All right, there is a second example here, but I think we'll be done after the second example because this is a lot of stuff. So let's do the second example, and then we will be done for the day here, because each example here clearly takes us a long time, which is okay because it's supposed to. This one here says the number of calories in some of the Subway's 6-inch sandwiches are as follows. Calculate the standard deviation and variance for the data. Well, here's the thing. Let's keep in mind that that this is just some Subway sandwiches. So, very key word here I'm going to highlight is the word some. This means that this is not the population of all Subway sandwiches. This is just some Subway sandwiches. This is just a sample of Subway sandwiches. So therefore, we need to calculate the sample mean, not the population mean. So we're going to be finding X bar. And it also means for our standard deviation, we're going to use use S, right, rather than the other symbol for standard deviation, right? That Greek letter, which I actually forget which Greek letter that is because I'm so used to seeing that and thinking standard deviation. But anyways, we're going to be using S, right, in this case for sample standard deviation, which is equal to, the sum of our sample mean, X minus our sample mean over N minus 1, all square rooted, right? So this is what we're going to use for this situation today. Okay, so first of all, we need to find the sample mean. Now, keep in mind, these are 10 of the sandwiches, so we need to divide by 10 here. So if we do that, we're going to get 2,146 divided by 10, which is 214.6. The average, calories in one of these specific Subway sandwiches in this sample is 214.6 calories. So now I'm going to write out all the numbers of calories here. So I'm going to put my x's here, then my x minus our mean, and then my x minus our mean squared, like that. Okay, so 219, 248, 215. Let's go down a little bit here. What were the other numbers? 213, 219, 161, 254, 232, 223, 162, like that. Good. Awesome. We did it. Okay, so now let's do x minus x bar. So x bar, just a reminder, was 214.6. So what's 219 minus 2.146? Well, that's 4.4. How about 248 minus 214.6? Well, that's going to be 33.4, and then so on and so forth, right? We're just taking each of these values, each of the x values, and we're subtracting this 214.6 to get the rest of the values. So I'm going to just put those in quickly here because I think you all get the idea as to how to subtract two numbers and which two numbers to subtract in these cases. Good. Awesome. All right, now we're going to take all these numbers and we're going to square them. Okay. So 19.36, 1115.56. Amazing. Okay. Awesome. Well, we did it. We did it. All right, so next what are we going to do? We are going to add up all of these values. So what's our total? What's our total of all of these values? It's going to be 8,722.4. Okay, so now let's put that back into this equation up here and say that we have 8,722.4. Divide by 9, and then let's take the square root of that. So let's do that. So 8,722.4 divided by 9 is equal to, 969.156 approximately, which the square root of that is 31.13. So therefore, in conclusion, our standard deviation is going to be 31.13, and our variance is going to be the standard deviation squared, which is going to be 969 point, what was it, 156 approximately. And there we have it. There it is. All right, well, that was everything for today. I do suggest to continue practicing this. I would suggest only practice maybe one or two of these at a time because these are long, these are tedious. They do take a long time, so I think it's good to do them just in short spurs because they can be quite frustrating, unfortunately, just because of how many details there are in getting something like this right. But that said, I hope this was helpful, and we'll continue next time with perhaps a less tedious topic. Next time we'll be talking about scatter plots and linear correlation. I'll talk more about the meaning of what that actually means during our next lesson. But for today, have a good rest of your day, and we'll see you for the next lesson. Bye, everyone.